Sorry.
There we go. Hello everyone, welcome into yet another live stream. There we go. We're rolling. So for
Awesome.
this stream, I'm gonna also going to give you on
Oh yes, that will
Discord
be good. Thank
live
you.
one. There we go. Professional on the listen. You have your own personal live stream on Discord. So hello everyone. My chat is absolutely broken. My chat is 100% complete.
Sweet.
Oh no, it's not. Hi there, Happy. So yeah, so let me show you what I wanted to do for this live stream. When it comes to, it's not really what I wanted to do. I wanted to teach me a thing or two about waves and help me tackle a problem. So first of all, let's get some basics to make sure that I understand how it works and just we're on the same page. So here's the thing. For the drone, I will need to use brushless models. Now, I haven't done much research because I wanted to leave it all for this very live stream. Hi to Ayash, hi to Hub, by the way. Also, y'all say hi to Tefta. Tefta's here. I guess I should have given you,
Hey,
like...
I'm here.
There we
Ta-da!
go, yeah, sick. Now, so the way brushless models work, if I'm not mistaken, is you have like magnets in the middle. No, that's what I call an artist interpretation. I should do it in 3D. And then you have coils on the outside in pairs, like this. And 6 is actually they sometimes have 12, but it's always 3 circuits. So then you have 3 separate cables coming out of it. Let's use purple, green and yellow. In reality, I'm pretty certain it's black, red and yellow, which once again very confusing because normally black and red are supposed to be for voltage and ground, but whatever, black, yellow, red. And if I'm understanding this correctly, if I power them, if I first power the purple one, this thing inside is gonna rotate by 1 cycle. If I then power the green one, keeping the purple one negative and the yellow neutral, is gonna rotate by another cycle. If I then keep this one positive, this one negative, this one neutral, then it's gonna rotate by another cycle, and so on and so forth, spinning around. And basically, what I wanna end up with is a wave in which we would have sine x. This would be our first cable voltage. Then you have sine of x plus pi seconds, second wave voltage, and then let's keep this black. And then the third one, which would be plus just pi. And that's kind of the purpose of the ESC, which is to basically have these 3 DC. So have the DC supply for each and every single one of the magnets and have them oscillate back and forth like this. And now my question was, how should I go about oscillating this DC signal back and forth?
Okay, yeah. And so this might be lack of information on my part. I do believe that they use a pulse width modulated DC signal as opposed to an AC signal. And let me just double check that.
Hi, what's going on here? Hi there, Alex. Basically, oh, it's a long story, actually. It's quite a long story. First of all, I want to make a drone. Actually, it's not that long of a story. I want to make a drone. In order to make the drone, I should use brushless motors. In order to control brushless motors, I need something which is called an ESC, which will basically be used to convert just DC power into, here we have an ESC, and then it will just convert them into a funky wave signal with 3 different inputs, which will then be able to connect to the brushless motor and have the motor spin around and around. And so right now, basically I want to figure out how to approach the ESC. I was thinking capacitors, but I don't know if that's a good idea. So I'm gonna give you some time. In the meantime, I'm gonna. Sounds cool. It is actually. I mean, it is cool. So I was thinking this. Okay, this I know it's probably not gonna work, but my idea was to do it with capacitors, which would make this whole thing really cheap. So basically, when you have capacitors, the sort of the whole shtick is that you input DC, and then when you have a capacitor, it fills up. Then when it's full, once it's full, it's releasing all of that charge. Then it fills up again. Once it's full, you release all that charge. So if you just input DC into it, right, like this, then what you're gonna get out is something which should look like this, which isn't exactly a wave. That's kind of my whole problem. Oh, hold on, the wrong way. Up, down, there we go. Something.
So it looks like they use an H bridge to invert the polarity, but I don't know if you need to actually create a full blown AC signal in the sense that it actually switches polarity, right? That is the first thing I don't know.
Oh yeah, because okay, yes. I mean, here's the thing. When you have these three, right? So for example, let's say that we have them this configuration. So the reason why you want to switch polarity is because you want this one to repel the magnet and this one to attract. This one to be neutral. So these are neutral, then this one repels the magnet, this one attracts. So these two would have to be opposite polarities in this case.
Yeah. And I think that that is the case. I'm actually asking AI just to double check that I'm not being wrong.
Yes, so basically you want
Yeah, it's
something
a
like
three-phase AC signal. So yeah, so not only do you have to have this create you pretty much mapping exactly the waves that you show. So in this circuitry, not only when you pass that zero mark, it's actually applying a reverse voltage. So you'll have a positive voltage and then a negative voltage.
yeah.
And it looks like that's accomplished by an H bridge, but I'm not.
Hey,
And that's why
right.
ESC circuits I think are difficult.
Well, if it wasn't difficult, then it wouldn't be fun. Basically, want something like a power inverter. God, that's well. I need to give power a specific shape. It's not the best explanation, but you basically want to power them in succession in a very specific way. So,
Yeah,
and
that you can
that's
control.
yeah. So basically, we want to have three signals with voltage going like this for all of them.
Yes.
Wait, this is wrong. This is wrong. This up, middle, down. Why is it the two middles right here? That's wrong. Hold on. Wait, mathematically it doesn't make sense. You would need a fourth one? Yeah, you would for pi times 1.5. Am I going crazy? Oh, because it's not gonna be pi. I'm an idiot. Yeah, don't mind me. Don't mind me. I'm an idiot.
No, this I don't know. I'm actually interested in this.
Oh, H bridge, right. Electronic circuit that switches the polarity of voltage applied to loads. Yeah, so pi third. I think so, but
I'm
then
not
they
sure
won't
if we
mix
need.
it up. I'm actually gonna check flybook tags.
So there is a BLDC that doesn't use an H bridge, and then for brushed DC motor ESCs, they use H bridge. BLDCs. Yeah, so they usually use BLDCs. So how do they?
Do you want to have three outputs or one output the shape of three waves altogether? No, they're three separate outputs. All of these will go to a separate output. Because basically each and every single one controls a different pair of coils right here. I think they're coils. Yeah. Coils, magnets, coils. So we have first input, so you have first wave which would control first wave which would control this one, second wave which would control this one, and then third wave which would control this one. And they all need to get alternating. Just need to convert DC to AC and then delay two of the outputs, right? Yeah, well,
We'll mostly need the MOSFETs. So we're gonna have to look at some MOSFETs that they're gonna help with. They're gonna amplify the signal because we're gonna have the microcontroller send the data to the transistors to then send this high current because we need to protect the computer from being fried from this high voltage or high current. So I'm going to look at the circuitry of an open source one to see what MOSFETs or what transistors they're using for the main one.
I suppose I could load into KiCad too. Probably.
Yeah. That'll be helpful, actually.
Yep, and just was open source Arduino ESC. There we go. Is there a KiCad project download somewhere? Download PCB is.
Oh, there we go. The schematic. Those are the Gerber files. That won't show you. They probably don't supply you with that image in and of itself can be recreated though.
Yeah, I was just hoping that we could load into KiCad and walk with it, move it around and stuff. I suppose image would be okay. Alright, first, three-phase bridge. Okay, this is the meat and potatoes we mostly care, as I mostly care right now, because this is the secret.
Yeah. And let me look up that part. What is that part? I'm trying to find that.
IR2 101. That's what I'm gonna.
Yeah. IR2 101.
IR2 101 STR. I just want to mention how proud I am of the fact that you said that part, and I feel like such a smart boy that I figured out which part you were referring to with absolutely no description.
That's awesome.
There we go, I got the data sheet. So, it's a high and low driver.
Awesome.
Fully operational to 6. Okay. Oh, wait, is this really?
Oh, awesome.
Power MOSFET and IGBT drivers, or lowercase l, in which case it's LGBT. What's an IGBT? I appreciate the laugh too. A bit of a feel, but yeah.
Insulated gate. So it's bipolar. That's awesome. Because you need it to be able to switch. Okay.
Oh, so it's just like a transistor, so bipolar transistor for high powers, if I'm understanding this correctly.
So this is the main integrated circuit. So this is like your.
This looks like it solves 90% of the problem, honestly. Maybe I'm misunderstanding this, but
no, and that's most integrated circuits. They make them for a reason, for single purpose, and it's on like one.
Yeah, I suppose that is. I suppose I should have expected that, but this really seems. Wait, and no to as in no, it's not solving, or no, I'm not wrong. I first would like to clarify before I say anything else. My lawyers advised me to.
Yes, no, you're correct. This does most of the work for you, but what we'll need to know is how it talks. So what we're looking for is the way that it's talked to, and I'm guessing that's going to be either SPI or I2C.
I don't know if you already have the datasheet, but I just sent one.
Oh, sweet. Thank you. No, I don't have the data sheet, so now I can grab it. And that's what I'm going to look for.
I guess it's playing Doctor Tune Mechanical Group in such hacker music from Soda. It just fits
So
perfectly.
awesome. What? Did it pop up? Dang it.
Okay, I suppose I should be. Alright, huge sip of coffee and
Download. Oh, it's gonna
let's
just
go.
download it.
14 pages, 14 pages PDF. Ah.
So okay, gate match description.
Uh, maximum ratings, no. Recommend operating conditions, don't care, dynamic, don't care, don't care. Functional block diagram, nope. Hi, the Charmer. I'm just gonna open Checkup. Supply. So we have VB, high side floating supply, high side floating supply return. By the way, if you're thinking, feel free to mute me. I'm sorry.
It's a
This is just
serial communication protocol. So we might how you interface it. Yeah, it's a 2-wire interface, but it looks like serial. So you pretty much just use 2 wires to communicate with this thing, and you can control its properties. So sometimes a board is pretty smart and will have like an SPI interface or an I2C, and it's just a communication protocol. This one, it might not have that robust of a protocol that you talk to it.
But I mean,
Yes.
I'm a
So,
C programmer. Not having a robust protocol, I'm actually a big fan of that.
yeah.
Okay, so wait.
So
Where'd you?
the drivers are independent high and low output channels, proprietary HVIC and latch immune CMOS. Okay, blah blah. It's 3.3 logic. The output drivers, yeah, operates up to 600 volts. That's crazy.
Yeah, I mean, it's as I mentioned, 600. That is insane.
So yeah, it's nice. This is pretty low level. This is very low level.
I like it. Huge fan. I mean, I'm not even kidding. I have to see. This is the go on first.
Yeah.
Before.
So it looks like this is kind of how we're controlling it, or you're controlling it. Sorry, I'm pasting this in the.
Not understanding anything at the moment. I know for sure won't, so I'll go now. Happy stream. Good night. Good night, Shama. Don't worry, I'm not understanding anything either. But that's the fun of it. Okay, so yeah, we're looking at the same. So we have high side. So
input.
high side, low side. That's the issue. I'm just going into high side versus low side circuits.
This is the nitty gritty of engineering.
I'm not gonna lie, it's fun. Even I prefer this to chemistry any day of the week. I know when it comes to engineering, I'm gonna call it engineering. I said there's a different term, but that's what I'm gonna call it. When it goes to engineering, I know about as much as chemistry, but I pick this over chemistry every day of the week. So much better. I want to make clear too. I'm not saying that engineering is much easier. I'm just saying it's way more fun. And the difficulties of things are fun.
Yeah.
Connected between V and load because of just walk, it can be more difficult to use.
Sweet.
The transistor was coming. Yeah, don't really.
So we'll need 3 of these. We'll need 2. Yes.
3 for every single phase. So I mean 3, so 1 per
This
phase.
can drive half. So it says the IR21 can drive 1/2 bridge, 2 transistors at a time. So we'll need at least 3 drivers for a complete BLDC motor. So 1 per each output.
Yeah, so 1 per each phase, basically. 1 per each coil.
So the VB pin, you connect this to the positive supply through a bootstrap circuit, typically consisting of a diode and a capacitor. So yeah, this is super low level. So how we're going to integrate this with the pins is we're going to control its frequency pretty much just through some of the circuitry, I think, and some of it through the microcontroller. So we will need to build a circuit for this, and that's why that other picture has some other items in it. So the VB pin is for the high side floating supply, and we connect this supply down capacitor, and this provides the necessary voltage for the high side driver. And the connect to the common
Okay,
ground.
hypothetically,
in the
let's
HIN,
assume...
so the high side input, you connect to a PWM output from your microcontroller. So the main HIN, the high side input, that's where the microcontroller is going to send the pulse width modulated signal. And so pretty much that's how you're going to time and activate this. The low side, you would also connect the PWM output from your microcontroller, low side driver. And
Wait.
so why you'd have to do this, I don't know.
Wait, hold on. What's the difference between low side and high side? Yeah, I'm on that level.
Yeah. No, I don't actually know either, right? So what we're doing is we're using a low voltage to control a high voltage.
Because if apart from that, it would seem... Wait. Oh, wait. Low side. Isn't low side... I might have a stroke of... Is this my make it smart moment? Hold on. Why am I using this? I have an AI. What is the difference between high side and low side in circuits? Hey, Make It, what are we doing? Hi there, Oreo. We're trying to figure out how to create an ESC, and we already found, well, Tefta found this, which is a finished open source ESC, but because I'm cool, I want to make my own, which will basically mean using this to be an ESC, and it will mean that I won't really make my own. I'll just use this one, the high and low side driver, as my ESC, and then we'll have to add a couple of things in order to actually make it work. Positions of semiconductor
so the
switch.
Low side,
yeah. Input one and it switches, input the other one switches the other way. So
yeah.
So it's not 1 is equal to open, 0 is equal to close. It's 1 is equal to the action of opening, and then 1 in the other channel is the action of closing. So no idea what any of that means, but sounds cool. Oh, don't worry, same here. I have no idea either.
So the low side is a switch connected between the load and the ground. The high side is a switch that is connected between the power supply, high side, and the load. So when the switch is turned on, it connects the power supply to the load, allowing current to flow from the supply to the load. So yeah. So this is how we're manipulating the circuit. It's pretty low level. Wow. this is we're having fun.
Okay, so
yeah, so it's their position in the circuit. High versus low means the position in the circuit. And this is pretty advanced because we're taking a DC signal and trying to get an AC output. So the reason why this is so difficult is that usually you know,
You go the other way.
electricity flows one way. Yeah. So now we're going to have to not only go flow one way, but when we reverse everything, it could have different properties. So there's certain things we have to worry about. And how you do this is by basic circuit design, and these integrated circuits that people put together with the common things that you need. So these are meant to take a pulse width modulated signal from a microcontroller and then output DC voltage. And so it looks like the two pins that we're going to use for the PWM signal are the HIN and the LIN, the high side input and the low side input. So that's what we're going to be sending the pulse width signal, saying, hey, high side input, operate this way, and then LIN is the low side. It doesn't look like there's not an output. So you don't read from this chip data-wise. You literally just send it PWMs through
I mean,
two
it's a really, I mean, in comparison to the larger ones, it is a simple one, so we know the output. Ideally,
Yeah.
obviously, if nothing is wrong, then we know the output.
Well, let's look at that circuit design. Can you pull that up? The one where there was
Yep.
4 of these or 3 of these? Okay, so on the left side there, let me make this full screen.
Wait, H, L, ABC, that
So
goes from a... Oh, is it not down anywhere? Of course it's not where it would be.
Yeah, so what they did is they named them A, B, and C on
Yeah,
the left
A, B.
side. AH, AL, BH, BL,
Yeah.
CH, CL.
I'm just
And so
wondering...
those are all connected to PWM outputs.
Oh, that's where they are.
On the very top right, yep, the
Yeah, okay,
Atmega
yeah, okay.
328, yep.
AL, B, BL, CL, right here. Okay.
And so those pins on that microcontroller, the Atmega, are PWM outputs. So you have to make sure that the pins that you're using, so that you have the ESP32S2,
Yes.
all of those pins that are outputs, all 27 of the 32, because the other ones are just for power. The 27, all of them are pulse width modulated. So it doesn't even matter what pins you pick on the ESP.
So just 6
as
pins.
long as it's not ground in voltage. Yeah. Or there's actually also you have the EN pin, which is for turning different states on the board. So you wouldn't want to use that pin either. That's why there's 27. Not.
Wait, hold on. I mean, correct me if I'm wrong, but we can disregard the buzzer, right?
Yep.
We can.
We don't need that either.
We don't need that.
Yep.
Wait, main input that's just power. So this is we can simplify.
That you will need.
Yeah, I will need, but this is
actually,
way simple. But in our case, it would be way simpler. Since it'll be smaller, we won't have like a separate section. BEMF voltage drivers. How and what now?
Voltage
where?
Dividers.
Dividers.
I don't know why. It's probably because this board is being operated on both 3.3 volts and then at whatever those motors are. Let's just say they're 5 volts. I believe that's the voltage dividers and just a simple resistor setup, so that way only so much goes to the microcontroller. That's my guess. I do not know for sure.
Yeah, so we won't care about this either because in our ESC we will have a separate power for the ESC, separate for the board. This will be in a whole other place. This will be for. This won't even be on the ESC.
So it looks like that is connected to the outputs because you'll notice the voltage dividers are for
phases. So this.
Yeah. So they're connected to that. That has to do with the motor output, but I don't understand it yet, so we can just leave it off. Because the 3-phase bridge is the meat and potatoes of what we need.
Yeah, this is the ESC. This is the ESC. And power block wait, what's the power block?
Power block at the top. What chip is that?
It's a lot of
MP230.
This is electricity. When you have 6 capacitors, I'm pretty certain, with 22 microfarads, if I'm pretty certain, in parallel, and
it's a step down DC converter. So they're probably inputting. Let's say usually those batteries are 3.7 or whatever 7.2, depending on how they're set up. So it's a DC to DC down converter.
Okay, hypothetically, let's say that someone watching the stream wouldn't exactly know what that means, right? Not me. I understood
So
perfectly.
you have one battery, right?
Yep.
In the drone, usually you have this big chunk of battery because you need a lot of power,
Yeah, I
and
have
you're gonna have
just okay.
yeah,
3.7 volts.
and so yeah, they're usually so batteries are usually charged to like 4.2 volts and they discharge to like 2.9 or whatever. I don't know the actual numbers, but
Oh,
that's a
this
whole
is to
circuit just to keeping batteries charged, right? But then when you use a battery, it's gonna output like 4.2 volts, and then it's gonna drop
Oh,
down
so this is
as
to
when it's
keep it
supposed
at
to
3.7.
discharge. So yeah, so the capacitors are used to kind of level out the output,
Oh, that's okay.
smooth them out, and you're also down converting it from. You don't want the 7 volts. Let's say if two batteries are in series, it's going to be double, one of the battery voltages. So you want to drop down some of it to 3.3 volts for your microcontroller, and then you want to downplay the others probably to 5 volts, right? So we're going to be dealing usually with 3.3 volts of logic for the microcontroller, uh, and low amperage, and then we want high voltage, high amperage, 5 volts for going directly to the motors. And since our batteries are probably going to supply us with 7.2 volts, we're just going to have a down converter. And sometimes they have two outputs. So sometimes the DC to DC buck converters or whatever, if we're going up or going down, they're different names. But the ones that go down, sometimes they supply two voltage outputs, sometimes not. So
Okay.
that's my totality of my understanding. So I hope I answered your question.
Yes, you did answer. Honestly, okay. Can I just say that this is going so much better than I was expecting it to go. I was expecting to just
kinda
sit here
fun.
and nod in silence without understanding anything, but it actually all
Yeah.
okay. So I feel like I'm like a 5-year-old, showing off a cool painting their panels right now. But yeah, if I understand correctly, and
Yes.
I'm really hoping I do. First of
I
all,
hope I
in
am
red.
as well.
First of all, in red, we will. So things we certainly will not need. So these. Maybe not lighten overlay.
Ooh.
I'm a professional. Or let's just do 70 with normal. So
There we go.
So we won't need, certainly won't need these. All right.
Yes.
Now, the red is, so in red we have everything we won't need because we're optimizing. So because we're optimizing for weight and price, we will basically try to, things we really don't need. Main input, that's a tricky one. Do we,
Yeah. So we want that. So
but this is
the
just
UART
power,
pins
right?
and the
This is just,
main input piece pulse with modulated input. I do not know what they're doing there. I don't
I
understand that.
think
yet.
if I understand correctly, is yellow. So yellow would be things which we don't need in this form. So we don't really need. So for example, this right here, this at the top, we don't need them on the ESC. My point is, we will have. We don't need them on the ESC because remember we will have 4 ESCs, one per motor, and so these will be just centralized in the center of the drone. There is no need to have them on the ESC. Same with this. All of this also will be in the brain. This will be in the power supply. This one will be in the brain, if I may say so. And then one thing, and then 2 things left. So first things first, which will be green, and that's the actual ESC. This is what we care about. This is the money shot. This is the gold.
And the voltage dividers.
Yeah,
too,
and then
those would also be green.
I actually, that's what I was gonna ask. If green or purple, because I honestly have no idea. I have no idea what this is. I mean, I know what this is. It's a voltage divider, but I don't really know if I don't really know ESC wise if it's necessary.
it looks like
Because
it's
it's
definitely
dividing. Yeah,
necessary.
it's dividing per phases. I think this should be
Yeah.
honestly. I think this should be yellow actually. The reason why is that shouldn't voltage divider shouldn't this I feel like this just should be one large circuit with the voltage dividers.
Yeah. I think the three-phase bridge would include that and be green.
Yeah, we'll just have the voltage dividers before the three-phase bridge, or rather
Okay.
this mirrored and then just going right into phases. Okay. There we go. And so, yeah, honestly, this is actually really hopeful because remember when I mentioned that I actually wanted to contribute something?
Yes.
If we get, first of all, that open source ESC is already much better than any ESC I could get for the drone. And second of all, if we really get rid of these red ones, this is already gonna be better. Not crazy lot better, but technically better. I don't know, I keep saying we. And I keep saying
Yes.
we because I really want to acknowledge the fact that you are a tremendous, like helping me like crazy. But at the same time, I don't really want to use we because I feel like that's putting a lot of pressure on you. Because I
But
did
no,
not ask
I'm a
you
part of
in
the
any.
audience.
Yeah, but like I did not. I just want to make that clear and go on record that I did not ask Tefta to be a part of the project, and the reason why I want to go on record is that so far it's everything is pointing the fact that this will be a colossal failure. All right, so I just want to go on record as it stands right now. The project is a bad idea, okay, and I did not actually ask Tefta to be a part of it. Tefta is just helping out because Tefta is just an extremely nice person. Your microphone sounds a lot better, make it. Nice job configuring it. Oh, does it really? Probably because I'm yelling. Okay, I'm sorry, Tefta. I just wanted,
No, it does sound good.
just wanted to make that, clear because I'm self-aware. Okay, I'm self-aware of just how silly it is to make a drone and make an ESC for that drone in 100 days, with no prior engineering experience. Because it's not actually that silly of an idea if there are people who actually know this stuff. But yeah. Believe make it that you will
Yeah.
fail the make it grind set. I mean, we'll see. We'll happy.
So I got the image blown up now, which is kind of nice on my screen, so I can
Yep.
look at the design.
There was a way to.
So yeah, so the main things is that we need 6 pulse width modulated pins to control the output. And then we have to worry because that's our data portion, right? So we have 6 data pins that we're sending, and then everything else is power or circuitry. And that's the AHAL, BHBL, CHCL. And so that part's pretty easy. And so we know what this chip is that has the 8 pins on it. And it looks like they're using some capacitors and this IRLR7843. I'm gonna look that up. See what that is. IRL 7843.
Was hide the magic mask. So this is just planning and not really prototyping nor designing, planning the ESC. ESC, which is a piece of circuitry made in order to control brushless motors mostly. Not really, but that's what I'm gonna use it for. Alright.
Okay, so this data sheet I downloaded.
So we have com, which is the... Alright. Sleepy, happy, I mean, quit deleting your messages. Very distracting. We care about the schematic of this. There we go. Okay, there we go. That sheet. So, yeah, so Hin and Lin are just 2 pins used to control the thing. Then VS is high side floating supply return, which goes into the power divider. Oh boy. pushes ahead.
So I sent you the link for the data sheet for the other component, and this is a companion. You'll need 3. Well, actually, you'll need 6 of these, and that's on the bridge on the left.
Yep. I'll check in a second. I'm struggling using Discord, and I'm trying to design my ESC.
Yep, there you go.
Okay.
Data sheet.
So I'll actually might as well right now. So this is the
Yeah, it's the Q1, Q2. It's the Q symbols on the schematic on the very left with the 3. Yeah. Yeah, they're right there.
These ones. Okay, got it.
Yeah, Q1, 2, 3, 4, 5, and 6.
All right, I will look into it soon. Only first, I would like to find A's. A6, A7. A, sick. Wait, why is the board
yeah.
inputs? Wait, what is a PC pin?
Were you seeing that?
PC. PC0, PC1. Or, wait, oh no, or are they the same as PB and PD?
Oh, let me check. Where you at?
Top right corner, the...
Oh, top right corner. You're looking for PC something?
PC kind of pin. Like you have ADC. Is it the same as PD and PB? Hi, the Feeble.
Yeah, so an ADC is analog to digital.
Yep.
Yeah, I don't know. So, PC. I'm not sure what that's a designator on the board. We'd have to look at the Atmega 32. But that Mega 32 would tell us what type of pin that is. But I can just tell you that they're pulse width modulated capable pins, is my guess. But it looks like A0 through A5, those are analog pins, I'm guessing.
Okay.
6 of them. But so on the board schematics, they would be called PC0, PC1 for the Atmega 32. Like the actual chip would have those on the pins. But how they're referenced in the Atmega proper is probably the A0, A1. People can give those different terms, but it's just so you can look up on
I know A. Oh yeah. Oh, so okay. Yeah, but that's what I was thinking.
Sometimes
because
they're
like
arbitrary.
there are PB, B, C, D, so that's the alphabet. So
yeah,
that's what I was thinking. I was wondering if that was just the alphabet to kind of divide them to 3 different groups, or if that actually meant something. Sleepy, that's happy.
I don't think it means anything, but I'm gonna look it up just to check.
Yes. I think so. I'm gonna. Okay, so. Oh my goodness. Okay, I'm gonna brush up on how voltage dividers work in the meantime.
Electric engineering is mostly reading data sheets.
Honestly, engineering in general is just mostly reading.
Yeah,
I feel like
sheets.
I don't even know if engineering is just mostly reading. That's it. If you're programming, then Stack Overflow. If you're engineering, then datasheets. That's if. By the
So
way,
it looks kind of arbitrary, and I'll copy this.
Yeah, it probably is. This is a 3x3 voltage divider. Come on. Oh.
Yeah, you picked the probably the most difficult circuit, the DC to AC circuit. I don't think you could have a more difficult. I mean, dealing with microwaves, it's kind of the same thing. Higher voltage and also AC, but it's darn near close. I think a microwave transceiver is about the only thing more complicated.
That will be my next product.
Yeah, let me jump headfirst into E.
Okay, that's how I roll. Hey, I've never coded before. Let's make a graphical engine.
I think it's really good to take a look at this image, though, the block diagram for the Atmega 32, because you can see that the pins are associated with like UART1, TWI, SPI connections. So there's a lot of, yeah.
Oh, wow.
So they're just arbitrarily, like
Okay.
on the ESP32S2, you would actually see, hey, this is one of the different cores, or blah blah blah, or the pin names are different.
Can you just appreciate for a second that people who make all of these things could just like give us a table, or even no table at all, or just describe them in words? Can you appreciate for a second that for some reason every single person that works with electronics actually making these diagrams, which is so handy.
Yeah.
There are a lot of these tiny ones which are only described in like a single document with just words, and I hate them every single time. You have to just read through the entire thing and then understand what 16 different pins do.
Yeah.
It's just like really obscure ones. So organized. Yeah, it's just nice. Okay, so... Alright, so... Oh, you know what? Since I don't want... I'm gonna start with something which I think like would be decent for me. I'm gonna try to figure out this 3x3 voltage divider.
That would be interesting because I actually don't know.
I feel like
how
in this
that's
case,
used.
I'm gonna, yeah, I mean I get the idea of a voltage divider. I just wanna really understand exactly how it's used. And this is something I can actually do because I did do a couple of electricity live streams. Did do a
Yes.
couple of them. The question: why do people in quantum physics hate infinity? What do you mean hate infinity? Mathematicians absolutely love infinity. In quantum mechanics is mostly mathematicians. Mathematicians who are pretending to be physicists.
Don't all these things go to infinity?
Yeah, as I mentioned, the mathematicians just love infinity. They're huge suckers for infinity. This like top favorite thing. Physics people. Yeah, but quantum mechanics is mathematicians masquerading as physicists, okay? So, you know, it's not really physicists. Right.
I can get lost in these diagrams sometimes.
I know, I feel you. Trust me, I know what you mean. Now imagine what it feels like when you're actually new to this. Why is it pasting in black squares? It's not a black square. Photoshop.
Get your act together, Photoshop.
There we go. Photoshop, how about photo supermarket? Alright, so...
Oh, it's because it's a PNG. Sometimes it does that, right? Because it's a PNG, it actually sees the background as black. That's the alpha channel.
but
Photoshop
wait, but
will sometimes fill the alpha channel with black.
that's
Same thing
so
happens in
smart.
Illustrator.
That's I love Adobe products. That's so intelligent. When you have an alpha channel, just
It
fill it
is.
with black. It's just, you know.
Yeah. Don't
Oh,
go
it's
with
a
like,
real
you know,
thing.
gray or anything.
Yeah, I mean, don't keep it as alpha. I mean, if only Photoshop could handle alpha channels, right? You know, we created, we basically, in Photoshop, we have an AI which allows you to take any single portion of the image. Where you can have an AI which selects a certain object in the image. You can have an AI which fills the portion of the image. You can have an AI which fills a certain portion of the image, but we haven't figured out technology which lets us keep the alpha channel.
I think Adobe sees this as technology for stopping people from plagiarizing. I honestly think that the method of copying from a web browser is the only time that you see this. If you download it and open it, you will never get it.
Yeah, I know, which
It's
is
only when
so
you copy and paste in your clipboard.
so weird
So it
because
seems like an anti, because Photoshop wants to protect people that create, you know, intellectual property. So
That's fair, that's
therefore, they might get, pushed to do stupid stuff like this. That's my theory.
Hold on,
Whether or not it's true.
Rajan just right now. Sir, much respect to you for doing this for charity. I'm a student, so I can't support financially or watch the stream as I have to cover my study, but I have liked and subscribed the channel. Thank you so much, and don't even worry about the whole not having enough to spread charity. I don't want people to feel guilty just because they can't contribute. It's understandable. The entire idea of charity to be, I mean, you know, people who do charity are called volunteers for a reason. It's supposed to be voluntary. If people are being forced into it with guilt, it's not really voluntary, you know, is it?
But also the emotional support of people just cheering you on.
Personally,
Personally, I think that's
that is
helpful.
huge. YouTubers
It
live on
seriously
that
is.
too.
Just
So.
saying, Yeah, exactly. Good job. I mean, everyone needs a pat in the back, so
I,
I
I,
think that's
I
what they're
already
trying to say.
mentioned it before, but I have just a Tefta playlist on Spotify. So when I can't talk to Tefta and I still want to get the effect of, Tefta telling me good job, I just play the playlist. It's the most uplifting songs I can find. Make an app so you don't get the problems with taxes. That's what taxes are. Forced charity. We found the yeah. I hate my taxes. But on the other hand, I don't want to go against the IRS. Oh my, 3x3. Oh, whose idea was it to work on this drone project? What kind of idiot came up with this idea? Ah, okay, 3x3 voltage divider. So, okay, so first of all, this voltage divider has 4 inputs. I mean, 3 inputs, 1 output. No, wait, 2 inputs, 2 outputs. Normal voltage dividers have 1 input, 2 outputs, which means there's 1 additional input in that voltage divider. That's probably
Yeah.
because it's a BEMF voltage divider.
Oh, they made another nice diagram.
Voltage control resistor. Free-terminal active. Oh. They responded to my message. Also, the video on the quantum mechanics was just so good. See you later. Bye, and yes, it was solid. It did get quite a lot of. And soon I'll be releasing another quantum mechanics video, and
Oh, it's
Tefta,
super cool.
yeah,
I've seen a preview.
yeah.
It's super awesome.
See, don't take my word for it.
It's worth the wait.
Hopefully I can publish it today. Actually, when I get bored, I could make it and destroy the paint of my wall slowly. Just whatever gets you out of bed in the morning, I suppose. In what world is this a voltage divider? This is called sadomasochism, not voltage divider.
So we have the D6 pin on one side, and the D6 is just one of the pins on the Atmega. So I'm not sure why that's there. But the A0, A1, and A2, those are ADCs. So you can read those 3 channels.
Yeah, so
So the microcontroller will tell you what the voltage is on A0, A1, or A2.
oh, that's the
The
usage. So
DC, yeah. So I'm not
wait.
sure what the DC is, but that's
Oh,
just
then
connected
this
to
is
a
this.
pin.
Wait. So A0 through 2 is just for reading.
Is for reading the analog.
Oh, then that's
signal.
such
Yeah,
a
those are
such a.
connected to the ADCs.
Okay, then this is a much simpler actually voltage divider. Well, not much simpler, but
I
it's
think
simpler.
I think it's telling you the output of the phases. So this is a safe way of reading the voltage output from the ESC. I think that's what this is. It's dividing the voltage so that way you can read A0, A1, and A2 within the voltage requirements of the ADC on the Atmega. Because
But
you don't want to read the 5 volts at 1 amp, right? Or 2,
yeah,
7 amps.
precisely.
Who knows?
Well,
That would fry you.
frying the
So I think
circuit
that's
is
what this is.
suboptimal. Okay, but hold on.
So
Phase.
D6 is some kind of
Wait,
output, I think.
phase is going. Wait, is phase the phase is the input of the IR2, right? This is the input, not the output.
A, B, and C, I think, is the output. Phase A, B, and C is the output directly to the motor.
Okay, wait,
wires.
so
that will go directly to the coils.
Wait, once again, what is D6? I know you just thought.
D6
Oh, that's
is on
where
the left
D6
side
is.
Yeah.
Okay.
And then D6 on the pins, it doesn't even have analog signal. It's just actually it is. Never mind. D6 is analog too. But they labeled it a D on this schematic, so usually you only do that for digital signals, but
I'm going
that's just
to
how I design.
I'm going to
Because they would have called it A7 or something, but
I'm,
they decided to call it D6.
I'm going to switch the BMF voltage divider then to yellow. I know it's risky to not yellow, as in, maybe, as in maybe might have, because I know it's risky to not have a way to read the voltage, but I'm hoping that with a simple enough circuit it wouldn't matter.
It probably matters a lot because if you miss timing on a clock, right? Like, I don't
Oh,
see any timing mechanism, right? So what is timing this whole thing?
wait,
If it's
but do
just the
you
loop in the
need,
microcontroller,
hold on, do you need timing though for a motor? Because if you
yeah.
miss
Well,
timing, then
yeah, no, no. Just think about this: a
oh, you mean like
quadcopter
synchron?
that you can't, you can't change because you're going to be changing the speed at which the motor turns. So the faster the AC signal is, the faster the motor will spin. So in order to control the throttle, you're going to increase the frequency of the sine wave for each
Yes.
of the three phases. Yeah, so your whole method, you require timing. The you need timing in order to have to
Wait, but
control
you
how
need, but do you
fast the
need,
motor turns.
do you mean timing? So like synchronization in between these bridges, or
So there's a pulse width modulated signal that's being sent to this, right? The high and low. So that signal gets sent to this, and then from the pulse width modulated signal, that IR 210 or 2101 is somehow now magically changing it to AC. I don't know how it magically changes to AC yet,
you know what?
but
I don't exactly understand, but I try. But I get the idea.
yeah,
I
because we're kind of
trust.
reverse engineering how this works. Sleepy is just adding stuff.
Yes, this
Um,
is typing the
yeah,
entire alphabet.
so we send it a high signal and a low signal to
And
one of the
also, you know
phases.
what?
Let's say
Yeah, you are right. I should switch it to green because also this is a very simple circuit. I misunderstood it completely. The red dots means that the cables are not intersecting, or the wires are not intersecting, which makes it a
yes.
really simple circuit. Like
So
an
you're just reading the three outputs.
unbelievably.
Yeah, and resistors.
This is just three voltage dividers on top of each other, and that's an unbelievably simple circuit.
Yeah. And I think, and so
This
you're
is
going to read that, and just in case your, let's say your controller or your computer somehow misses a step, you're going to need to read it to make sure that you send it. You also need some feedback from the actual motors. So this ADC is going to tell you a little bit about how the motor is operating. Because let's say there's extra resistance in the air or something, you could
mhm.
see if it's skipping or something. So yeah, all of these that you'll need in order to kind of put into your PID system that you're controlling.
Wait,
And
ADC as in,
analog to digital
yeah, but
converter
which ADC?
on your microcontroller. Yeah, whatever is going to be controlling the motors. In this case,
Oh,
it's
that
the
okay,
Atmega 328. Yeah.
okay.
So it looks like we're using so far 6 pins for the phase bridge that are pulse width modulated, one data pin for the voltage divider, and 3 analogs. So we'll have we'll have 10 pins that we'll need, data pins, to the microcontroller.
Okay, still, I'm having a real hard time actually. So, uh,
Yeah.
so okay, so you have D6 and A0 through 2,
Yep.
and D6
D6.
is the this is just the voltage coming from the three-phase bridge, and this is
I
right.
think your DC is your reference voltage. I'm pretty sure DC is somehow the
D6,
reference. Yeah,
D6 is
D6. Sorry.
okay. So okay, then in that case it's
It's
simple.
acting as a.
A0 through
Yeah.
2 we can use to measure the voltage,
Yep.
and then D6 is the reference in this case. Well, that actually
I think
explains
it's
it.
used.
I mean, it
Yeah.
would explain it certainly. It certainly would explain,
So
because otherwise I
yes,
have no idea why D6 would be there.
yeah, and the thing is that you're on the right side. You have the high voltage, the phase A, B, and C. So, and then on the left side and the top, you have the low voltage, the 3.3 volt logic. So the D6 is going to be helpful. Um, I bet you it's a fancy way, because if you can imagine the logic on the computer, it's at 3.2 volts, then it's at 3.4 volts, let's just say. Well, the ADC will also be reading that voltage because it's a part of its own circuitry. So this is probably a fancy way of making sure that you're reading properly on A0, A1, A2. That's my guess
So
for
six
why D6
pins.
is there.
6 pins, and all of
Total of,
them.
yeah,
I mean,
so
10 pins.
there
10
will be
pins. 6 plus
10
4.
pins. 6 of them are sending out data, 2 per each 3-phase bridge, or 2 per each motor output, motor input. And yeah, and so those 6 pins are going to be sending out signals.
How many
D6
pins?
probably will be sending out too.
Hold on. How many pins does a ESP have?
On the dev board, you have 27 pins at your disposal.
Oh no, that's not
Why?
enough. That's not
For all
not
of
enough.
these,
That's not enough for the ESCs alone.
27, because you need only 6 per, and then 3.
You need 10
have
per ESC, so 40, which means we would need we would basically need to have like a separate. So we would basically need to have the. This is what we would need to do. We would need to have the was drawing tool. This, there we go. We would need to have the ESC right here, right? Which would take it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then into these 10 pins, we would need something which would then take from the ESP.
No, because I think I'm pretty sure this can. Oh, 4 motors. Yeah.
ESP, yeah. Then from the ESP would take would need to take 4 pins total, maybe, because we would need 3 for measuring. We need 3 pins for measuring the motor, and 1 for controlling the speed and direction. Which means we would need something in the middle to turn these 4 into 10.
Yeah. You can do that with a multiplexer, but you want to make sure that you.
No. I mean, like, yeah. That's the issue, is that we basically want something to turn because this will be this wouldn't be digital, right? This will be analog. ESP can. We can have the analog, no problem. Yeah, so we would need something which would basically okay, if you think about it as a program, then it would basically turn the information of analog, it would pass it into a different, so it's kind of like converting a file from JPEG to PNG. Right, so we start with a PNG, and then we start with a JPEG, and then we convert it to PNG, which would have more data but also a larger size. So out of one analog pin, we can already figure out this. We can figure out all of this. So one analog pin can take all of 6 of those. It's just we will need some logic in between the ESP and the ESC to figure out what should exactly look like. And that's the tricky bit. What could we possibly use for this logic? Because hardware solution would be best, hardware solution would be cheapest, software solution would be easiest. Hide all this.
Yeah.
What are we
you
doing?
can also get another integrated circuit that maybe talks via SPI or I2C that you can send this information to. I'm looking up what other people are doing.
Wait, how much do like small? Hold on. What are they called? The microcontrol? Not microcontrollers. The chips, the tiny chips, which you can program with assembly. The really tiny ones.
Yeah, yeah, they're
What
like
if?
a integrated circuit, like a tiny
Yeah,
MCU. Or
programmable integrated circuits. Because if they cost something like $2, which they might, or wait, no, less. If they cost something like programmable logic divides and electrochemists to reconfigure digital circuits, not digital. I'm kind of looking for analog, but the right track.
that's why they probably use an STM32 is because it has enough pins on it.
Wait, STM. Oh, it's okay. I mean, if this will, okay, but this will be really fun because FPGA programmable
Field
logic.
programmable gate array.
This would be really fun because okay, software side, I'm all for it. Because software side, I would just sit down during one live stream and then spend 8 hours working on it, and it would work in the end.
Yeah, so AI is saying that the STM32 series is a good one. That's why most of them that I've seen so far that I've looked up use the STM32. The ones that were showing me the circuits. And it has numerous. Yeah, the STM32F7. The data sheet.
Oof, that's
Beefy.
okay. Yeah, it's chunky boy. It's quite a
Looks like it has 100 pins.
wait. STM32 F7
F407
F407. Okay.
yeah. So that's an F722. That'll probably have enough pins. They're expensive, but they'll have enough pins that you control everything.
Okay, define expensive.
$8, $5.
Okay, it's no, it's pretty solid. Wait, isn't this pretty similar to the ESP?
Yeah, the ESP it is, but the ESP, the different variants of the expressive chips, um, have different numbers of pins. Because like the one that you have, the ESP32, because this is to make a drone. Uh, ESP32S2, it actually has even more than 32 pins for GPIOs, but you only have on the dev board 32 at your disposal. There's actually
Oh,
much more if you just had the circuitry yourself.
oh,
So the
that's
dev
fine.
boards are just
Then that's fine because with the
yeah. So,
dev board, I can just basically make the ESC for one motor for which I will have enough pins, and then I will just have
yeah,
to make more. And if it works, I can just make multiple ones and just get instead of the dev board, use the actual chip. Wait, so
yeah, you can, and you could have them all talking to one another using the SPI protocol too. So you could have like 4 ESP32s on the board if you want, not even use the Wi-Fi board.
yeah, I that's probably. I mean, probably I will probably have something separate for. I don't think I will need Wi-Fi. If I'm going for the for radio frequencies anyway.
Yeah, so the S3 dev kit.
ESP32 has 43 physical. Oh, but then the controller. Damn it! It's always something.
Well, but look up the S3 because the S3 has, I think, we'll have enough for you.
S3 pins. 45. Two more. Okay, it's Okay, it's okay. I mean, I feel like okay, but if we do re-go this, we're wasting pins. 6 pins per ESC. That's a bit much.
Yeah. Well, you could also look for another integrated circuit that could then control those. Uh, but yeah, the requirements are kind of high for it. It's a lot of pins, but it is a very complex thing.
I'm gonna ask Bing. I'm looking for a cheap, um, tiny micro. I don't know it's a micro. I don't know cheap tiny chip which I could program order to pass the data from a single analog pin and output it into 6 digital, right? The H in
Yeah.
and L in are digital. 6 digital pins.
So looks like, check this out. This person actually has an open source ESC.
Oh, it's a
So this they looks like they'll supply you even with the build files. So this you can actually send to the manufacturer yourself.
wait, but isn't this is a single motor ESC though? That's taking so many pins in. Oh, wait, that's a mini USB.
Yeah, it doesn't mean that you need all the pins. Like if you look at some of the other
Yeah,
pictures,
I
there's
just
only
realized.
yeah. You probably would just connect 4 pins to it.
Mm, I don't know why at this point, the making the ESC myself seems surprisingly doable. Oh, I got answers. Oh, I got answers. Oh my goodness. Um, PCF
So
8591.
so this
That's
is a open source or trying to make a drone from all the circuitry using the knowledge. Drones for what?
oh, hold on. The heck is oh by the way, hi Hungry. Sorry, I didn't see that. Didn't get notification Discord. Oh, did I not? I might have not notified anyone in Discord. Whoops. That's on me. Don't worry about that. Drones for what? Charity. That's streams empty charity streams. Alright. I mean the PC oh that's what the PCF is. What's the price though? It's just dropship money with drones, unlock transactions. Oof.
So yeah, so the ESCs, those are the meat and potatoes, because how you control those would be how the drone will turn or go up, go down. So yeah, that's pretty much the main part of it is interacting with the motors and getting the feedback back.
I'm just
The second part
I'm
is
just really
also then
scared
the
of
transmission
I'm
of
just
the
really
data.
scared of wasting the pins on the ESPs because those are the most important ones. It will have to handle the movement, the communication, and if I spend too many pins on the movement, then there'd be nothing I could do with communication all of a sudden.
Yeah, because you will need some, either it's a separate board that you have connected, so you'll need that, which most likely is going to be a separate board. You'll have the main computer controlling the motors, and then that will send a signal to another device that most likely will handle the radio frequency. For starters, just one, I'm guessing.
No, how many drones? Yeah,
Yeah.
for starters, hopefully one. For starters, honestly, for starters, if I could make 1/4, so like one motor with one ESC, I'm already satisfied. And in order
It's
to
funny how
make,
narrow focus. Sorry.
to go on first.
In order, I get so narrow focused when I'm looking at the circuit for one motor. I'm like, oh, that's simple. It's only just one motor. I'm like, oh crap, this is
Yeah.
there's four of them. I'm like, oh, I keep on like getting tunnel vision when I look at certain things, and I kind of forget because you can't really look at the big picture while you're zoomed in super close on like one piece.
Yeah.
At least
Also,
I can't.
I mean, the thing is, in order to make everything on time, I would need to have the ESC done next month. If I have
Yeah.
the ESC done next month, then actually then I would be really comfortable because scaling it up will not be an issue. You just literally just make 3 more ESCs, and making the first. If I make the first one, that means I already have the design, I already have the everything. Just make 3 additional ones. There we go. All the ESCs are done. For motors, I don't need to worry about that. I'll just motors I won't make myself. So you'll buy them. Have you seen these drone balls that
Probably
use
300 on motor.
heat sensor? I could honestly, I thought about it, but it's just not for this project. I thought about making my own motors because that actually sounds like fun. Use heat sensors on the bottom to make the motor spin faster and make it lift more. Wait, heat sensors? What? On the bottom to make the motor spin faster. How do heat sensors make the motor spin faster? I'm gonna play some epic gamer music because I. Whoops.
Maybe they use the heat sensor of like your hand to know that it needs to go up.
Oh.
So maybe that's just triggering it. That's my guess.
Right, epic gamer music is
rat
playing in the
produced-
background. Hell yeah, fuck that. Hell yeah. Yeah, I listen. I keep all the like most dramatic music for the best live streams. So for gaming, for example, I don't play any music. When I'm doing science, I play Soda. When I'm designing stuff with you, be fast, right?
Oh, I uninstalled the finals.
No, I haven't played the finals in. I haven't played finals in such a long time because I've been so busy.
They got rid of the sonar grenade for the medium class.
But they added some additional stuff. They added like something which allows you to go through walls, I think.
Yeah, the portal for the light. This is like a light class
there are portals, there are things which just
Yeah.
vanish parts of the map. Gravity is funky. It looks fun, but I just don't have the time.
Yeah.
I just
Well, like I literally I just trained with the sonar grenade as a medium, and I was doing decent, and then they just removed it. They literally moved it to the light class, so the
really. Oh,
medium
that's
doesn't even get a sonar. Yeah.
such a huge buff to the light class.
Yeah, I
There was a
know
reason
exactly.
why.
So they,
I mean, light class had a motion detection grenade, so it was basically like a less powerful version of the sonic grenade, where it only activates if someone was directly on top of it. And
yeah,
the
yeah.
reason why it was so much weaker is because for light, knowing where the opponent is huge. Could be something that
Oh
isn't
yeah,
waves. I
the
know how.
image shared in Discord.
Oh wait, image discount. Let me check. Um, it's it's this. Oh yeah, this is just detecting the hand and then just moving the models quicker.
That's a simpler mechanism.
That is a simpler
Just
mechanism
two blades.
than doing a freaking brushless model. Who came out with that? Using brushless models, silly, very silly. Hold on, programmable integrates. I'm looking basically for a microcontroller which is tiny.
Yeah, they're all tiny.
Yeah, but like tiny,
Like the
tiny.
RP2040. RP2040. It's
Oh,
super tiny. Yeah, because not on the dev board,
oh
the
yeah, RB21.
RP2040,
That's right.
it's super small.
Oh, I mean tiny as in simple and that's cheap. That's what I mean. I'm price optimizing. How much does RP? Oh,
Yeah, so
that's so many pins too.
yeah. But even the reason why it's bigger is because it has shielding for the Wi-Fi and stuff. But the RP2040 doesn't have Wi-Fi or anything. So literally everything on the RP2040 is yeah. So it would be a good little board to use because what is it like 3 millimeters by 3 millimeters?
Oh yeah,
Talk
but
about tiny.
when it comes to tiny, I mean
I have
cheap.
one.
Oh, because Sony made like the.
Well, if you just get the RP2040, 2040
What do you mean we're all waiting? Oh, Alex has
yeah,
been here. Alex has
it's
been
80
here.
cents. It's 80
80
cents.
cent.
What are you talking about?
Wait, the RP
Digicade.
2040.
Yeah, it's the guts of the Raspberry. Yeah, it's 80 cents.
Well, then we
That's
found
at
the winner.
one.
There, wait,
Yeah,
unlock. That has unlock. It has PCI opens, right?
it has four. It has four. Yeah, but only three of them can be used because one of them is for voltage.
Wait, hold on.
So
So,
yeah, you'll have three at your disposal.
we have
And I
three
think they're 12.
unlock pins, and
Yeah.
how many? Oh, why am I? Why am I? I can just look at the data sheet. Pin
Yeah.
out. I know I'm bugging you with this. This one, sick. So we have. Wait, am I looking at the right one?
Yeah, probably. RP2040. Yep.
That's so many pins. Yeah, this would solve a
Yeah.
problem.
So it's eight. Yeah. So you'd have four of these, one for each of the modes.
One for each model. Yeah, and then we could have Photoshop.
And you.
Then we would
So you
basically
will
have
have
ESP.
to make sure that. Yeah. So you'll probably use serial peripheral interface (SPI) connection to talk to it. So that way your main microcontroller could talk to it, and I think you can have like 120. I don't know how many devices, but all of them would share the same wiring. So each of the RP2040s could talk to the main microcontroller. Just all of them only using four of the wires. For
which
the main
means
microcontroller.
we would basically have ESP on which the program would be childishly simple. It would be basically game dev level simplicity, where it's basically like just move up, move down, easy money. Then RP would be the difficult one, where you basically have to pass the data from how much up, how down into what the ESC needs, and the ESC wouldn't even be a microcontroller. ESC would just take this and using these three integrated circuits, just 1 times 3, just turn it into what the modern. This is doable.
Yeah.
So
Yeah,
doable.
you just want to make sure that the frequency that the speed at which you can talk to the RP2040 is fast enough to control the motors. I don't know if there's a certain frequency
Oh,
that you
you're
need to hit
right.
for these, right? So there's some other specs that you want to look up, but this it gives you a really good overview of the project because you're looking at pieces of everything, which is a really good start.
I mean, this okay. This is a lot, but this is also 70% of the difficulty of making a drone. Of
Yeah.
the drone I want to make, because obviously I won't go through the exact same process. I won't, implement the communication myself. I won't implement the visual myself. No, when it comes to the camera and when it comes to the transmitter, I will actually just buy some. But this is what this.
Yeah.
Oh, that's great. I am
Yeah.
so
I think the
glad
RP2040
I have you,
will
Theft.
will
I am so glad. Can you imagine if I tried to do it myself? How long have I would be streaming for? Been streaming for hour and a half. No, this would take me 16 hours to figure out normally.
yeah.
Question: is the
That's
brain
great.
for drone as supposed to be an actual controller? Um, is the is this the brain for the drone as supposed to control? Okay, so let me explain to you. All right, now that I actually get what we're doing here, let me actually. Oh, maybe I don't need to use blend out, use paint. Let me actually explain what the problem was and the solution to it. So we have. It's all actually about abstraction because everything is about abstraction with me. You have the motor, right, and then you have the user. And the user, for example, knows that they want the motor to spin in a way which would cause the drone to go up, right? But now the question becomes, how do we get this information into the exact specific kinds of um, voltage that the motor needs to move this way? And so what we're basically doing is, I'll skip over the first part, which is the user actually, inputting into some sort of controller, this controller transmitting into the boring stuff. And then we have the ESP, which will be our board. And when the ESP gets it, then what we'll do is we'll have the ESP kind of figure out the data. So figure out which motor, how high up should go. So, we have 4 motors, and ESP will, based on the movement inputted, ESP will figure out how quickly each motor should spin. And then it's gonna give this information into the RP2040, which will only take in a number of how fast the motor should spin. And then the entire point of RP2040 will be to turn that number into 10, to separate it into 10 pins. Are those 10? I think, no, it's 9. 10 pins. 6 of which will be responsible for moving the motor around, and 4 of which, well, 3 of which will be responsible for figuring out how quickly each coil is powered, and 1 of which is just there because might as well. and so
Yeah.
and so what we basically did this last, and then the last bit, which is the ESC, and ESC will be responsible for taking these 6 pins and, based on them, switching the voltage on and off to actually input it into the motor. And then the motor can, like, the conversion from position to control the joystick, the necessary voltage to equivalent potence. Yes, exactly. It's conversion from here from the joystick to the movement, here from the movement to a number, here from a number to a pinout, and here from a pinout to a voltage. Precisely. And
you will probably need a gyroscope to know how the
I completely
drone
forgot
is
about that.
oriented.
Oh yeah, but
So
that's
that will just be connected
yeah,
to the main.
yeah, and that's great. That's why I want the RP. That's precisely what I mentioned, because if I actually use the ESP pins, then I would end up like, oh yeah, great, okay, sick. We used 40 pins for the we used 40 pins for the motors, right? We use, let's say, 2 pins for communication. We have 3 pins level is great. And then all of a sudden, it's like, oh, you also need a gyroscope, which takes in 8 pins. And I'm screwed. Yeah, I'm not gonna add more pins to that. So that's why the RP 2040 is it's just great.
So yeah, so the RP2040 will have 4 pins connecting to the ESP, but the nice thing is that all of the RP2040s will share the same 4 pins. So the ESP only needs 4 pins to talk to all 4 RP2040s. Which is nice.
Wait, what? I don't.
The communication. So the ESP is going to connect to the RP2040 via 4 wires or 2 wires mostly for data. But they all can share the same 4 wires. So you're only stealing 4 pins from the main ESP.
So because you need
16 pins to the ESP. Otherwise, you'd be taking 16 pins of the ESP. But in this case, we only need 4. Because the type of protocol allows that.
Okay, that's I sure. See. I'm a C programmer, right? That's remember when I said about the ESCs. I'm a C programmer. You're talking protocol. I was thinking of implementing my own. I completely forgot that protocols exist and like are a thing.
Yeah.
I thought I would have to implement it myself. So yeah. See, that's why it's convenient to have someone who actually knows, who's actual expert. Because my silly dum brain would just try to implement a protocol on my own, which it would be.
I actually
great.
did that. I tried to do that too, and then I realized, oh, there already exist I2C and then I2S and SPI.
So it's always the first answer is like
straight up there. It's just like, yeah.
I got an idea which might interest you. Go ahead, Happy. A clock that goes by heat instead of time. I'm pretty certain that's just called a thermometer. Actually, I'm pretty certain that's what it's called.
A thermo.
Thermo detector.
Thermographic detector.
Flashlight. I think you mean the photon blaster.
Yep.
Electron-powered photon blaster.
So then you will just need the gyroscope, which is usually just another integrated circuit.
Yeah, for the gyroscope, I mean, pins. Not gonna lie, if as I mentioned, if at the end of the month I'll have a working, very important, perfectly working, that's should be mentioned, perfectly working motor ESC RP2040 ESP32 S2. I think we can go with S2. And all of them programmed, all of them perfectly working, I would already consider that a success. Because then I could spend the next month, because first of all, this will be the most difficult part. Not because it is difficult all by itself, only because this is the part that I actually want to make myself. And that's, I'm the bottleneck in this case. And so the next month, I could then spend just combining 4 of them together, which is easy, and then just working with things which already exist, like for example camera, so like for example FPV camera, like for example FTX transmitter, like for example an gyroscope, and there we go.
Yeah,
a clock that gets powered by sunlight, so it only works half the time. Sorry, just had to read it first. There you go on that.
Oh no, just one of the difficulties with this is that using the SPI, so you're going to be reading and writing information from those RP2040s, and it's really important that you have the timing right. Very, very nuanced.
Yeah, this will be difficult.
But that's a fun data input-output problem. Personally, I think that's fun.
It is. Also, one thing which I should mention, I will try to create an ESC without an oscilloscope, which is a choice. This is what it's called, right? Oscilloscope. I'm butchering the name completely. Yeah.
Well, technically, each one of the RP2040s is an oscilloscope.
Yeah, like, yeah, precisely. Technically, it would work. The downside is if something happens and the RP2040's output will not, like, if something will happen on the way, there's a problem in the circuit, and in the end it turns out that the frequency of the voltage will not be the same as RP2040 is sending out, then without an oscilloscope, I can. There's that. It is over. There's nothing I can do. There's no way for me to
Not much
debug
troubleshooting
anything.
you can do.
I
Yeah.
I'll just have to guess what's wrong. No, who needs information
like
for
the
debugging?
Yeah. You should become like an EE magician or what are those seers with the crystal balls. You're
Just-
like a source. What are they called? Seers?
oh yeah.
What are the people that they they know? They say they know your past.
The
Fortune
fortune
tellers.
tellers, yeah.
You're electronic engineer, fortune teller.
No, no, I'm just gonna
That's how you troubleshoot.
have a diode connect two wires to it. And I'm just gonna tap on every single thing one by one to to measure the
Yeah.
frequency. I mean, you can just see really quickly, right? That's all you have to do. Just really quickly,
Oh, yeah.
a real quick look on the circuit.
This is a very difficult first circuit, by the way. Pretty cool.
I'm already satisfied
think-
with the progress because it haven't really done even anything, but this is already good news.
So, is it going to be one board, or is it going to each of the ESCs are going to be their own board?
Each of the
Because this way,
well,
if you
one would be cheaper, right?
have each of the ESCs, no, I think it's actually going to be cheaper to make the ESCs separate.
But here's the thing. That's the question because each of them would be cheaper. But what if on a single board I would have ESP, RP2040s, and the ESCs? If I would just chuck them all
probably
on a
will in the
single
final
board.
product, but just to tell you, you should probably just
Oh yeah, totally. For the development, I should do it completely.
Yeah.
That's true.
I think because that's what I did. Like I had like 6 different boards which were just my test boards because it's really hard to solder these small wires. So really, I kind of orchestrate my own dev board that has my own in and out pins, and I usually use the actual dev board for the RP2040, as long as it has enough pins on it, which I think the Raspberry Pi does.
Wait, Raspberry Pi Pico isn't does the RP20 what now? 20 which one has the RP?
2040, yeah, it's the
Is
same
it
thing
is
as the Raspberry Pi
2040?
Pico.
Wait, hold on.
Yeah. So you can use the Raspberry Pi Pico as your dev board for the ESCs because it has the USB interface and everything,
So
and you don't care about size because it's just your dev board.
first of all, I don't care. You don't care about size. Great quote. I agree 100%. So 20. So this is 2040
Yes, this
on
is the 2040.
every single
And the
Raspberry Pi
Raspberry
Pico.
Picos.
So which
Yes,
means that
every
right
Raspberry Pi
now,
Pico,
right now, as we speak,
you
I
have this
already
board.
have all the logic with me.
Yes, and you
That's-
see those 3 at the bottom. That's the JTAG. That's how you debug
This was yeah.
that device.
I don't have it on mine.
Yeah.
Whoops.
But it does have enough pins.
Oh no,
has
I do
enough
have it. I
pins.
just have it in the middle. I'm an idiot. Sorry. I just have it
Yeah.
right here because it's a W. Wait, this is. You do realize what this means? I can tomorrow.
Yeah.
First of all, Xenon just is playing in the background. And right when I said tomorrow, it dropped it. But tomorrow, I can already start the work on logic.
Yes.
I can just do a coding live stream. I would need
Yes.
your help with.
Okay.
Oh wait, but Raspberry Pi Pico. Am I gonna do it in MicroPython?
You can. MicroPython is super fast
Ah.
if you use C types. So MicroPython has a built-in module called C types that literally allows you to do C programming on MicroPython. The reason why MicroPython is
Oh,
good is
never
it's like a bootloader. So it's an easy way of flashing code onto the board and interacting with the board.
Listen, would
So
you
yeah, if you use MicroPython, I would suggest C types.
would you perchance have the time tomorrow to just walk me to
Yeah.
because tomorrow start I can set up ESPs and the Raspberry Pi Pico?
Yes.
That's great.
Yeah, and you can the other alternative is you could use Arduino. You can program it with the Arduino IDE, and then you'd just be using I think it's C or C++ that you use and the built-in libraries. I'm not familiar with that, but I can still walk you through that process. But I like MicroPython just because it's easy to interact with the board. But
Listen,
as
I
you get
I
more
think MicroPython
serious,
is decent.
I don't know.
I think MicroPython
And
is
for open
decent.
source
There's a way,
projects, it's awesome.
but this is great. Cause wait,
Yeah.
I want to gloss over the fact this is day 3. Day 4,
Okay.
we're starting logic.
Yeah.
To be fair, normally you should start logic after some of the hardware has been done, because even if I'm finished, I'll have to order the where's this sucker? This I'll have to order these. I'll order like 10 or something.
Okay, so
Actually,
yeah, so
15.
so the thing is that I would suggest cuz like you could design this and have the manufacturer put all these cuz some of these devices are actually um, surface mounted onto the board, right? And that's actually stuff I don't even have. So and so you might actually design the whole thing in Logic and test it before you actually make it in hardware. So you might want to analog. So I wonder if there's non. Let me look at that part. What what is that main board again? I have it pulled up. Okay, it's the IR2101. Yeah, that one's easy. Never mind, because that has breakout pins. But the other one, no, everything is. You don't have to worry. None of them are surface mounted necessarily.
Oh,
You kind of lucked out there.
which means I can just buy them
Yeah,
and won't
and they'll
run
fit
the
onto breadboards.
sick.
Uh, I'm I'm pretty sure the pitch. I'm just looking at the pitch of these, so they'd fit on the breadboard.
This
I'm pretty
is
sure it's the right
so
pitch.
cool. I mean,
Yeah,
so cool.
but you will want those resistors packs.
I was hoping that I have enough resistors to find some that will fit, because I have resistance capacitors. Because I know that
Okay.
right here, right, this is
So,
what you mean. This whole thing.
yeah, you're gonna want all. So you need some 33K resistors, some 100 ohm. You
Yeah, when it
need
comes to
a whole
resistors, I
bunch
have
of.
plenty. I have some capacitors. Also, this thing. Wait, what is this in the end? I know you've sent me
That's the IRLR. It's a half bridge.
this.
What is it?
High
Yes.
frequency synchronous back converters for computer processor power, which is yeah, it just rolls off the tongue. Uh,
So this is probably some of the logic in that integrated circuit, right? It's like you need two of these to do, yeah,
I have
pretty low
wait,
level.
what are they though? High frequency oscillating DC converters from synchronous rectification for telecom industrial. I love how they give you all the graphs before
Yeah.
actually explaining. Mate, I don't know what this is even. Can I get like a pins explanation? You have VDS. Wait, voltage resistance and what even is Q? If you have to
So this is
use
like a
Q, that means your charge. Why not I? Why columns? Why not amperes? You're trying to make this hard. That's on purpose.
they're probably not. They're trying to make it as straightforward
But why not amperes?
because
Wait, are amperes or are amperes inverse of charge or just amperes? Am I? Wait, amperes are charge per second. 1 coulomb moving past. So okay, never mind. This is just wait per second. What's the charge? Oh, this has gotten way more confusing. Amperes are charge per second, which means this is like, imagine if you had a circuit which instead of having watts would have joules. Why charge?
Okay.
Is this the amount of charge it needs to do something?
So it looks like this is converting low frequency to, or sorry, low voltage to high voltage, DC to DC. So I think what this is doing is taking the data signal from the pulse width modulated
And then
signal and then
just
making it higher voltage.
okay, then
I
just
think
amping
this
it
is
up.
like, so yeah, it's just an, it looks like it's a high frequency though. So it's rated to be able to switch fast. So I think this is kind of like is the main transistor upping the voltage. I think the other thing is mostly just your logic circuit
Wait,
for getting
this is
sine output.
but this is getting
And
from
these two,
high output and low output. So this is going out there
yeah.
from oh no, this is high output, right? Low output. I'm assuming from the name. Uh, Output voltage, and then so this is amping out the output voltage, but output as in the logic output voltage. Is
Yeah.
it so that the
And it
logic
looks
would
like it
go
has a
through?
diode on it. So it has a transistor and a diode. So I think it's helping that it phase properly. So while it's going up, one of these is activated, and while it's going down, the other one is activated.
Wait, so is it the only so that the electricity will go through? Am I I
I
get.
think it's directly taking the pulse width modulated signal, amping it up
I mean, it's taking.
proportionally to the wave. Because I think that that's how it was explained to me. I might be wrong, but what you're not actually getting this AC line. What you're getting is actually a it's an AC. I have to draw a picture of it. I can't explain it.
What confuses me is that it takes in high side gate drive output and low side gate drive output. That's what confuses me. It takes in logic. It isn't taking the voltage, it's taking the logic. Oh.
Yeah, it's taking in the pulse width modulated signal from the controller. I think it's passing through the latch because this three-phase bridge is like a latch mechanism that's operating at a frequency, right? And then it's sending it here, and then this IR LR is upping the voltage from the PWM signal with the processed latch because literally this is logic in the form of circuitry. So it's as low level as you can get, which is kind of cool because all you have is a PWM signal. And then, but I'm trying to show you this picture because it makes sense. Because I don't think it's an actual PWM signal. I think it is actually a modulated PWM output, which makes sense when, oh my goodness, Illustrator. So it doesn't actually go up and down. It looks more like this, if that makes sense.
I can't see.
I just
Oh, there we
it.
go. Sick.
You know what I mean?
Not gonna lie, not really.
So you know the curve up and curve down. Look, if you were to just to trace the dots, it would be a curve up and a curve down.
Yeah, but what I mean, what confuses me about this. Let me show what. Okay, but here's what confuses me about this. All right. These, you have to remember, the red dot means they're not connected, right? Red dot
means they are connected.
They are connected to phase. Then first of all, I have no idea how this circuit works. Then this is a mess, and I don't want to get into this. But so they are connected. They're going to phase.
Yeah, the red dots is where they are connected.
Then what is a VS? Then okay, then I get it. Just what is VS?
VS where?
This VS on the IR2. Data sheets.
IR2.
VS is the high side floating supply return. Oh, so this is just excess voltage, kind of? Oh, then I get it.
Yeah, it's the main out is the VS. It's your voltage signal. VS is probably stands for the voltage signal, I guess. Or the supply. So this is the main output of this device.
Okay, so alright. So when it comes to the capacitor, All right, let me just go back to this. There we go. When it comes to the capacitor, diode, resistors, I'll probably have them, and this capacitor too. I'm assuming I'll have them. If not, I don't know. We'll see. And all I need to do right now is buy
Capacitors,
15 of those, buy 30 of those, and that's it. And then we can start building DSC. Once again, I'm saying we, and I'm sorry. I don't want to put pressure because, as I mentioned, so far is actually project is looking kind of hopeful after this live stream. But so far, it's way too early on to say anything, and I don't want to put any pressure.
No problem. No, I love learning. I really enjoyed this stuff. I have never done this, and knowing how to make an AC output for motor control definitely will be useful for some of my future stuff. So no, I'm with you.
This is sick. I don't know where to. I know.
Yeah, I think it's fun.
I don't know where I should buy them though.
Yeah, so I don't know. I usually will go on.
I mean, I can find them separately. No,
Arrow
just...
is a good place to get them. Or
Arrow.
Yeah, AROW.
As it, I mean, yeah, but
Arrow Electronics.
Electronics. Okay, got it. Because you know, if I just search Arrow, I'm just gonna get arrows.
Sorry, yeah. Arrow Electronics, and then there's also DigiKey you can get from, but DigiKey has some minimums. But Arrow, sometimes you can find some good ones, and then AliExpress. Usually, you can buy all these boards.
Yeah, but you know,
higher, but AliExpress.
It's gonna take a long time to the delivery. I want something where delivery will take a week tops.
Yeah, so DigiKey. I'm not sure what the European manufacturers are.
Oh wait, I can just search ordering. What would integrated circuits would be? Where to order integrated circuits in Europe?
Or just electronics parts. Electronics parts.
Euro pages. They're called Euro pages and they're from UK. This is not really. Base integrated circuit suppliers in Germany. Yeah, Germany's close enough. Distributor of Climbs EU. Alright, that looks like it. Do you have this? Searched entry not found. I guess you don't. Well, cool.
So the the best. Okay, has to be my favorite guy for electronics is the EEV blog. That guy is amazing. I don't know if you've ever seen his stuff, but on his forum they gave these 4 links, so I'm just pasting it into our chat.
All right.
But yeah, that dude is awesome. The Australian guy that talks about circuits.
There we go.
There was a space after it, but it got rid of it.
Yeah, this works. Okay, which one do we need exactly? We need IR202 STRPBF.
And sometimes the variants, like the last 2 or 3 digits, sometimes you don't.
Oh, it's in German. Can I switch to English?
Können Sie Deutsch sprechen?
Ich keine Sprache.
I don't speak.
Wait, am I having a stroke? Is that not how to speak English? Hold on. Here's the English.
Suchen. Just type in America.
America. Can I? Is it really gonna be American?
No.
That's not
Type
American.
in English again. Oh, because it's gonna be the German.
The
word.
German, which is so dumb, by the way. I hate when websites do that. I don't speak German. How am I supposed to know what German is? Oh, there are these. Never mind. Right there. Okay, sick.
There you go.
Okay, manufacturer. This picture is only for illustration. Well, that's not helpful. Okay, translating didn't help. This is the bad item to
No,
compare. I want to buy the
it doesn't look
item.
like. So it doesn't look like it. So which one are you on? The SOS? Okay, let me look it up.
Defano is also. Okay, Defano also has some, and you just have a button to switching focus. There we go. €1. Well, €1.44 per one. Okay, it's not kind of €1 is
So
not crazy.
but you should see on there how many parts they have in stock, because that's most important. So the availability, they have 9,700 in stock. That's good.
Yeah.
Because sometimes you also want to look for the minimum order. So the minimum is 1, which is good. So the bottom one has a minimum of 100, if you see.
Oh, this one has
So
yeah.
that's what you want
And
to
right
look for when
right
you're
here,
buying.
I'll
So
be cheaper
no.
by 15 too.
But
That
you see
one.
right by the add button, underneath the add button has the minimum.
Yes, I see.
Okay, gotcha.
I
That's
mean,
what
it's
I would
it's not
look
it's
for,
not
'cause
it's not the
sometimes-
first time I'm ordering parts actually in bulk.
Okay.
I have done it in the past.
I made that mistake because I kept on trying to find when I couldn't add it to the cart. I'm like, why is it not adding to the cart? It's like, oh, because the minimum order is 1,000. I was looking up ADCs. I got lost in the ADC world for a long time. What's marginally harder than finding electronic components though is springs. I found that to be annoying.
Wait, springs as in
Yeah, try to find a spring of a certain size and a certain.
oh, you mean like just
Tension.
a standard spring? Just a okay.
Yeah, I needed to find a very specific spring, and I was like, oh my god, I didn't know the world of springs was so tedious.
This is
Like,
such
there's
a
no.
such a specific problem too.
Yeah.
Actually,
Yeah, it's like
most people have never probably
7.5
ordered.
millimeter.
Most people probably never ordered a string, because
Yeah, what's funny is Fallout, how rare springs are. Fallout 4. I was like, I finally understood why springs are.
honestly,
so
I don't think
scarce
I've
in
ever
Apocalypse.
seen a spring for sale in my life.
Yeah.
I don't think I've ever seen a
When you get
spring for
into-
sale.
Yeah.
And that is true. You
almost
do
had
need an exact kind of spring.
Yes. Yes. It very exact.
It's such a specific issue which only people who need springs would find.
Yeah. I almost had to have a company make it, and then pun intended.
Okay,
And to do that, it's so expensive.
so here's the thing. Oh goody, stuff. Great. For one ESC, it will cost €9 per ESC. Just the
For the
sake.
prototype.
I think for the final might too. I mean,
yeah,
no,
that's what you wanna look at.
€9 just for the integrated circuits for the ESC. So
Well, in order to price it properly, you'll want to look at JLC PCB or PCBWay or another electronics manufacturer, because you'll probably be sending the PCB design to one of those. But JLC PCB is pretty inexpensive. But I'm sponsored by PCBWay, so
okay, well there we go.
PCBWay. they only paid for one video, but I'm pretty thankful.
Okay, but you're getting mixed signals. Should I go with PCBWay or? I'm getting mixed
Well,
signals.
yeah, doesn't matter. Both of them, you'll want to see if they have them in stock. So
Yeah, so
you'll
I
want to
just need
search for that
to-
component on their site.
By the way, you know how specific a component is if it has if it has 12 characters.
Yeah.
Resources, is it? Wait, hold on. What do you look for?
Let me go. JLC.
Yeah, I wanna find. I'm gonna. You know what? I'm just gonna send right here on the channel the name of these two things. There we go. These are the two we're looking for. Maker, what are you doing? We're just checking prices. I just want to know the difference between the prototype versus, because I don't really care about prototype costs. They'll never be
So
too crazy large for me.
here are the direct link to the JLC PCB components.
Okay,
circuit.
sick. All right, so first
And
one,
now you can just
no results. That's great.
we'll chop off the last digits.
Oh yeah, I suppose that's true with this. No result for
Okay.
IR2101. Yeah.
So then you might go to PCB way, because another thing is that this is gonna be helpful, because if you're gonna order the part, you want to make sure you're the company that's gonna finally manufacture it. Since I don't have the tech to actually make a PCB, to make sure that they have that in stock, and that helps you to figure out which components you actually want in your circuit. Like, I've had to change lots of my designs based off of what the available components were.
I can actually check where this, the noob, what's it called, Electro Noob, got their PCB, because they will probably
Yeah.
have the parts.
I'm guessing they made it themselves. That's why they didn't use surface-mounted parts, and they're using an at Mega.
I mean, okay, I could also always
Because
make
you
it
would
myself.
usually, if you made a PCB, you're gonna supply the diagram in the software that you use to design the PCB usually, because it's actually extra work to make the diagram that they did, as opposed to if someone just sent it in. So my guess is they didn't
Okay,
have it manufactured.
how
They made it
much
themselves.
harder is it to make your own PCB?
Order of magnitude.
I mean, I know, but I won't be making like 700 of them. I will be making number of drones
Order of
times 4.
magnitude in money, and in everything else.
Okay.
Because right, like, not only is it order of magnitude difficult because you have to have good soldering techniques, you have to have an equipment shop that has everything at your disposal, microscope. Yeah, there's a lot that goes into it, and then and it's difficult. But it's easier in the sense that if you make it yourself, you're going to intimately know the circuit very well.
Yeah, but I
And you'll
will
be able to
make it
quickly
myself for the prototype anyway. I was thinking about where
Yes.
do you find the parts in PCBWay?
But because you have a weight restriction, you're gonna have to have it manufactured if you have a weight consideration, because the surface mounted components that you can have in a custom PCB they weigh like a tenth.
Where can you find the parts on PCBWay?
Let me take a look for you. PCB. It's usually I go to their PCB assembly. That is a good question. Where is that? Module store? Oh. PCB assembly, instant quote.
PCB assembly overview. Component sourcing?
Yeah, component
Make
sourcing.
as PCB partiality command sourcing. Component sourcing service.
So it looks like they'll just find it for you.
That's it. You just sure it's convenient. Just add the name
Yeah.
and
It's kind of crazy though, the fact that how much work they do, like on these manufacturers. They're doing quite a lot of. They even test your circuit for you. Like it's crazy.
Okay, if you were to make a guesstimate, how much would like a single
Yeah.
ESC with? Oh, I completely forgot there are. No, wait. So how much would like a single ESC, which looks like this, cost? So this. I guess with
Yeah.
these voltage
So
dividers.
the price of the parts, the price of the PCB manufacturer, and the price of assembly. I would say in order to get any number of them, it's going to cost you $200.
Yeah,
If
but
they're
like per PCB.
depends on how many you buy. Yeah.
Let's just
So
say
just imagine
200.
one will, yeah. So one will cost 200. 200 of them might cost $300 for 200,
Okay,
maybe four hundred
okay.
dollars for 200.
All right, so
It's not
that's
that
so it's
expensive, but
really dirt cheap. That's good to know. You have
it's
to,
dirt
but you
cheap the
have to
more you make.
remember,
Yeah.
yeah, you have to remember. I completely understand that this is made for in bulk, but as I mentioned, the entire idea of this is that if I do prototype a drone, then at the very end I'm gonna start a huge action of collecting money for it, and then then I'll
Yeah.
plan on using all the money. So if we collect like 1,500 bucks, then $300 for PCBs. It's not really that huge of a chunk. It's 20% of it. So
Yeah.
so the
So
price in
what do we
bulk.
have for the? So we want to look at the cost. So we have a just $200 to manufacture any number. That doesn't matter. And then you pretty much just have the price of the components, and then just double the price of components, and that's the price for each. So 80 cents for the Raspberry Pi Picos, RP2040. So that would be $1.60. Let's say each of those is $1, so we'll put $6, 7, 8, 9. So yeah, probably like $8 per board or something. I'm not sure, but it's hard to run the numbers unless you actually run the numbers. So my estimate skills
Yeah,
are
that's what I
like
mentioned. Guesstimate,
0.
right? That's what it is.
Yeah, it's a guesstimate. So yeah, I would say that if you had all the components, you'd be able to see the price, but it could vary widely
So we just need to first
until you know which components.
make the drone. All right, this is
Like the U label was 235 for 10 of them, which was nice, and that was includes all the components, all the assembly, all the PCBs, and the testing. All I gave them was the designs.
I mean, I'm just tomorrow I can start. Okay, so I just need to order them.
I like that watching Make It is like life simulator. Sleepy said.
All right, so hold on. This, yeah. So right here it will cost me. Oh my, this is gonna be expensive. I wanted to order 15 of those, and I need two per each, right?
How much are they?
They are €1.
Yeah, so you can try to find the same type of part just in a different form factor or different limitations, because it's high frequency, but how high of a frequency do you need?
I
You
mean,
know, like the other something was rated to like 300 volts or something. I saw we were looking, and we do not need that much. So you could just find a lower um,
I'm just
accuracy
scared of
integrated
finding a
circuit.
different one for one simple reason. Right here, I'm using this sec as a guideline, right?
Yeah,
If I find different parts, I might need to match the resistors and the capacitors separately. If I find a different design, I might need to find
yeah,
I might need to figure out what is the how many farads I need and how big the resistance should be. And I have no idea
yeah.
how
That's
to
the
do
fun
that.
part.
I have no idea where to even begin doing that. Like, why are there
Yeah,
even two
because
capacitors
we
there?
don't understand. Yeah, so we don't understand a circuit. So understanding this circuit is important. what this device does, and I'll actually do a little bit of research because I don't know.
I
But
don't. I just don't know why. I mean, I guess I should probably find. Yeah, I might need to find these two. Okay, so that's the next goal. I need to find. I need to figure this out better. This right here, these two. If I figure them out
yeah,
better, then ESP is practically done. Cool. Like,
yeah,
I don't know.
it's a good third day.
That's pretty good for a day indeed. Tomorrow I'm gonna spend the day setting up the ESP and Raspberry. In 2 days I'll spend the day. Actually, it's always worth it. It's silly. That's it. That's a quote to live by. Nothing is worth the risk. The risk is always worth it. Tomorrow I'm gonna spend everything setting it up. Then in 2 days I'm gonna do a dual stream, coding the RP2040 and the ESP, and also second half of the last stream will be just figuring out the circuit, and then hopefully on today is Friday or Saturday. This Saturday, and hopefully on on Tuesday I should already have the first brushless motor arrive. On the other one, I don't know why I said first. I should have the brushless motor arrive, and so I'll be able to. Well, I won't have an ESP, but I will be able to test out the motor. Cool.
That's awesome.
It is. Wait, hold on. If I don't know how long the delivery is gonna take, but it will take. Wait, let me check. What was I using for the? I was using the German service. Germans are quick. That's racist. There we go. Screen main and the price for availability. What's the delivery? Farnell.com. Oh, it's Deutsch Farnell.
Well, it looks like I better hop off. My phone's starting to blow up.
Yep, don't worry. Thank you so much, Steph, though. Thank you so much for helping me. That was a massive thank you. Just thank you. And good luck, and bye. There we go. That if they went. I'm just gonna check one more thing, which is the delivery. So let's say you want to buy semiconductors, because why not? Dino diodes. This one. And then add to basket 100. Well, this is the wrong one because we'll need the one where we can buy only. We don't have to buy 100. This one needs to buy 5, but still fine. So let's add. We need 15 and 30. Actually, not 30. Let's do 25. No, 2, 6. 6 times 4, 24. Oh, I need 25. Yeah. And right here, I would like to add another 100. This is the right one? No, this is a minimum 100. This is the wrong one. I meant the other IR. This one. 312. €99. Deliver. Okay, handling charge. What's handling charge? Why is delivery free? I mean, delivery is free, but handling charge is €15. Sick. They call it baskets. Fast free delivery over 75. Oh, I'm so close. I might as well. Oh, hold on. Did I miss input? It should be 25. Update. Click for delivery information. Oh, why is it in German? May I in English? May I have it in English? Oh, come on. Can I have it in English, please? Anyone speak German? I'm actually gonna ask. Anyone speak? Anyone who speak German available at the moment? Everyone should learn German. I refuse. I'll never learn German. I mean, I could copy all of this, I guess, and then just translate it. Translator. A solid block of text. That's great. Oh, yeah, it's gonna take a bit. Did one break? Okay. This. Shopping cart. Short delivery times by placing orders before last order time. When selecting delivery method, orders for in-stock products will be shipped at the same next. Last time. We offer different delivery methods for your order. After your order ships, we'll send email notification that includes your tracking number available and track your order. But you can find more information about it. Okay. With delivery usually next working day, that's nice. Free standard delivery on orders over 75, usually next working day. So I might as well... Hold on, how expensive is it actually? Okay, so if I just meet the 75, it's gonna be cheaper. That's good to know. Hold on, if I go 50 and 24, how expensive is it gonna be? Way over, okay. So about 16. And wait, need multiple of 3. We have 69. We don't want 69. We want... There we go! It's actually cheaper to buy 21. Is this updated? It is. It's cheaper to buy 21 than to buy 16. This costs €100. This costs 91. Sick! No, it's still so expensive though. Fine. Alright. I'm gonna go now. I have to order this. Yeah. And that'll be it. Where's the logic? What do you mean, where's the logic? I mean, like, where's the logic in ordering more for the small price? These decrease and there isn't a... what's it called? Shipping charge. Anyhow, I'm gonna go now. For now, that'll be it. Thank you everyone so much for watching, and have a great day.